Hello dear students, welcome to Learning Chemistry is Easy and Fun. The topic that we are going to deal with now is empirical and molecular formula. And before we go on with this topic, an earnest request, please get a pen and paper ready so that you can also attempt the numericals that we are going to discuss today. So pause the video, a notebook and a pen please. If you are ready with the notebook and pen, please start with the topic for the day. What is empirical formula and molecular formula? Let's differentiate between the two terms first. C6H6, a very common organic compound that you must have heard about, and that is benzene. This can be represented as CH6, wherein the ratio of carbon to hydrogen is 1:1. Same way, C2H2, ethyne or acetylene, can also be represented as CH2. Again, the ratio of carbon to hydrogen is 1:1. This formula, which is representing the simplest whole number ratio between the different elements in a compound, is what we call as empirical formula. It is representing the simple whole number ratio. Note the term, it's not a fractional value. On the other hand, C6H6, C2H2, these are the actual formulas of the compound. They represent the actual number of atoms of different elements present in this. So, C6H6, meaning to say one molecule of benzene is made up of 6 carbon atoms and 6 hydrogen atoms. This formula is what we call as the molecular formula of the compound. It gives us the actual number of atoms of the different elements present in one molecule of the compound. So if you notice, our molecular formula is nothing but a whole number multiple of the empirical formula. So empirical formula multiplied by some whole number, that can be even 1, 2, 3, but gives you the molecular formula. At the same time, the molecular mass, the relative molecular mass, that means the mass of the molecular formula, will also be n times the mass of the compound represented by the empirical formula, right? So we make a note of these two formulas, which will help us in determining the molecular formula as well as the empirical formula. If you've noted, we will go on to the next one. To begin with, I'm taking a very simple question over here, wherein a compound containing carbon, hydrogen and oxygen has been given to us. We do not know the name of that compound, nor do we know its formula, but we've been provided with the percentage composition. That means the percentage of each element present in the compound. Whereas carbon is 40%, hydrogen 6.66%, oxygen is 53.34%. So what do? In your notebook, draw this whole tabular chart. So you have 1, 2, 3, 4, 5, 6 columns in all to be drawn. So once you've drawn these 6 columns, the first column is the one which is representing the elements, right? It is giving us the elements. Second column is percentage. Third column, atomic mass. Carbon, atomic mass 12, hydrogen 1, oxygen 16. The next column, if you see, it's a bit wider. Why? We're going to do some calculations over here. we've got to find out the relative number of atoms. That means corresponding to this percentage and this atomic mass, what will be the number of atoms of carbon in the compound. So, just like you did the number of moles, so 40 divided by 12 would be the relative number of atoms of carbon. 6.66 divided by 1, that would be the relative number of atoms of hydrogen. 53.34 divided by 16 is the relative number of atoms of oxygen in the compound. Pause the video and do the calculations. Give me the answers. So what do we have here? Did you tally the answers? Carbon 3.33, hydrogen 6.66, and oxygen is also 3.33. Now when we wrote the definition of empirical formula, we said simple whole number ratios, right? So how do we convert these ratios into whole numbers? Right. We divide each one of these by the smallest value which is there. So the smallest out of the three of them, now 3.33 and 3.33 are same. So we divide all the three values that we've got by 3.33. So that becomes your least ratio or the simplest ratio that we've got. So 6.66 divided by 3.33 and again 1. So what do we have over here? Carbon is 1, hydrogen is 2, oxygen is 1. In other words, we will have the empirical formula of the compound as CH2O. Have you got it right? Very good. Okay. Next, let's add one more part of the question. Determine its molecular formula if it is given to you that its molecular mass, relative molecular mass RMM, is given to you as 180. Knowing that empirical formula weight multiplied by some whole number value gives us the molecular mass, can you determine the value of N? How will you determine the empirical formula weight? Simply as you did the molecular mass. So 12 plus 2 plus 16 multiplied by N gives you the molar mass, that is 180. So N comes out as 6. Have you got this right? Very good. So we get the first smiley of today. Therefore, what will be our molecular formula? Very good. CH2O whole thing multiplied by 6. So C6H12O6 is our compound. Have you understood it in the first place? So it is better to do it in tabular form, but there are texts which teach you to do the same question in the form of a normal lines, like you can do it horizontally as well. No need to do it tabular. I find it easier, and the steps become very clear when you tabulate it and do it, but you can choose whichever way you like. Ready to do a challenge question? Should I give you a question to solve on your own? Let's see. I'm giving you a little tricky question here. It says 4.24 milligrams of an organic carboxylic acid on complete combustion gave 8.45 milligrams of carbon dioxide and 3.46 milligrams of water. Determine the molecular formula of this compound if its vapor density is 44 U. Oh, lots of data, lots of values. But there is no mention of percentage, right? So how do we go about it? You have an organic carboxylic acid. We write it simply as RCOOH. On complete combustion, that means combining with oxygen, it will give you carbon dioxide and it is giving us water. Even if you don't know the value of the carboxylic acid, it's okay. We are just writing a generic equation in order to understand, in order to break up the question. And that's how numericals are done. You've been given that you've got 8.45 milligrams of carbon dioxide. So let's down the value, let's write it down over here. 8.45 milligrams. How much of water have you got? 3.46 milligrams. The question clearly states that it's complete combustion. That means whatever carbon is there is getting converted to carbon dioxide. The hydrogen is getting oxidized to water. So how do I know how much is carbon over there? See, carbon dioxide 8.45 milligrams. Take the case of carbon dioxide. What is its relative molecular mass? Atomic mass, carbon is 12, oxygen is 16. So RMM would be, yes, very simple, it is 44U. Now in this 44U of carbon dioxide, how much is carbon over here? Very good, it's 12. So, mass of carbon or the weight of carbon in CO2 would be how much? And how much of CO2? 8.45 grams. So, let's word it differently. So, weight of carbon, can you calculate it in the meantime? Weight of carbon in 8.45 milligrams of CO2. Very good. So you get here 12 by 44 into 8.45, right? We are not doing into 100 because we've got the actual weight over here and that many milligrams. I'm leaving it for you to solve it and give me the value. Weight of hydrogen in 3.46 milligrams of water. Now apply the same logic. What is the RMM of water? Very good. Now it's almost orally done. 18. How many parts of hydrogen are there in this? It's 2. So multiplied by 3.46 milligrams is the weight of hydrogen in this. Pause the video, please do the two calculations and give me the value. So we've got carbon as 2.304 milligrams and hydrogen as 0.3844 milligrams. Have you got it right? Very good. So that there you get the second smiley of the lesson. So you're almost halfway through the question. Now if you notice, this carbon we are getting from the acid, carboxylic acid. The hydrogen again we are getting from the carboxylic acid. So these weights give us the amount of carbon which is there in 4.24 milligrams of the carboxylic acid. And 0.3844 milligrams is the weight of hydrogen in 4.2 milligrams of organic acid. Now what is left? We know the weight of carbon, we know the weight of hydrogen. What else can you determine? You also know the total weight of the compound. What can you calculate from this information? Super, you can calculate the weight of oxygen. So let's do that. So the weight of oxygen would be 4.24 milligrams, that's the weight of the compound, minus the weight of carbon and the weight of hydrogen which is there, which gives us a value of 1.5516 milligrams. Yes, we do it up to the 4 decimal places because we will further round it off. Now, you've got the weight of carbon, you've got the weight of hydrogen, you've got the weight of oxygen. You also have the weight of the compound. Can you determine its empirical formula? You know the tabular form, correct? So, what do? Carbon, hydrogen, oxygen you find out their percentage, because now we know only the mass. You put their atomic mass, you find out the relative number of atoms, that's your relative number of moles, and then you find out the simplest ratio. Now, something interesting over here. Because you have got mass and you've got the atomic mass, can we find the relative number of atoms from this data itself? Okay, so let's see the first method where we are talking about just the percentage. So percentage of carbon would be 2.304 divided by the total weight of the compound into 100. That gives you the percentage of carbon. Same way for hydrogen, it would be 0.3844 divided by 4.24 into 100. For oxygen, it will be 1.5516 divided by 4.24 into 100. That's a very long process, right? I know you're getting tired. Carbon 12, hydrogen 1, oxygen 16. Calculate the relative number of atoms here, calculate the simplest ratio, determine the empirical formula. At least till this point you do. Then we'll talk about the because in the question we gave, what value did we give you? Vapor density. I have not yet taught you the relation between vapor density and molecular mass. If you know it, well and good, because simple relative molecular mass is twice of vapor density. How? We will discuss this later, and that can help you to determine the molecular formula. There should be some easier way also to do this question, right? This is very long and tedious. You want to know what method is that? Let's go ahead with that. So let's see the second method. A part of it we are going to carry forward from what we did earlier. Let's see, what was it? Wherein we had found out the weight of carbon, we had determined the weight of hydrogen, we had also determined the weight of oxygen. This data we have jotted down again in a tabular form: 2.304, 0.3844 and 1.5516. What would be the relative number of moles of each atom present in the compound? You've been given the atomic mass. If you see, I've used the word moles. What does it remind you of? Yes, mass divided by the atomic mass. So doesn't it become simple for us? 2.304 divided by 12. Of course, this divided by 1. So remains as 0.3844, 1.5516 divided by 16. Get the values. Don't cheat. Try to do the question yourself. I am waiting for you to give me the answer. Very good. So we have over here carbon is 1.98. Just give me a minute. And we have carbon is 1.98, which we can approximately take it as 2. It's close to 2. And this is, of course, 0.3844. And 1.5516 divided by 16. You get it as, I'm waiting. I think I've gone wrong in the calculation here. Yes. The value over here is, yes, 0.192. Thanks for correcting me. Hydrogen is 0.3844 and oxygen 1.5516 divided by 16. So you get 0.0969, right? So this is going to give you just the relative number of moles. What do you do? What is the next step after this? Yes, you find out the least ratio. You divide all the three values by the smallest number. Now compare this. Of course, this is 0.3, 0.1 and 0.09. So which is the smallest out of the three? Very good. It's 0.0969. So divide the other two values by 0.0969 and draw down the least ratio that you get. Be honest, do the calculations. You will enjoy the video much more. So least ratio, we get it as 1.98, which is approximately taken as 2. Looks a little, yes, I'll just correct it. Yes, let me write it properly. It is 2, hydrogen is 4, and oxygen comes out as 1, obviously. So the empirical formula of the compound that you have of the organic carboxylic acid is C2H4O. This is our empirical formula, and the rest of the steps you know very well. Empirical formula mass would be 12 into 2 plus 4 into 1 plus 16. How much do you get? Calculate and then give me the molecular formula of the compound. So we get the empirical formula mass as 44U, right? Molecular mass is 2 into 44. Why 44? Yes, because of the vapor density is given to you as 44. Gives us a value of 88. So molecular formula or molecular formula mass is equals to empirical formula into N. We have 88 is equals to molecular formula mass is, sorry, the empirical formula mass is, we've got over here 44. So let's go ahead with it. Empirical formula mass 44 into N. Therefore, the number with which we multiply the empirical formula in order to get the molecular formula is 2. So molecular formula C2, we have here C2H4O is our empirical formula. C2H4O twice, and we get here C4H8O2. We know that. Can you guess which carboxylic acid is it? Carboxylic acid means we've got COOH, right? Now 1 carbon is used up over here. We are left with 3 carbon. Out of 8 hydrogen, 1 is used up over here. We are left with 7 hydrogen. So this is 3 plus 1, 4 carbon atoms. So bute, it's a saturated compound, so ane, and it's a carboxylic acid, so oic acid. So this compound is butanoic acid according to the IUPAC system of nomenclature, right? If you want to learn more about the IUPAC system, I have loaded 3 separate videos on IUPAC nomenclature alone on this channel. Have a look, build your confidence on this. So you've got C3H7COOH. Please check whether you got the same answer, or if you even write C4H8O2, it will be right, because at this point of time we've not taught you the organic. Once you learn organic chemistry, then of course you will have to write the correct formula of the compound. Let's go back to the first method that we did for this question, finding out the percentage and then determining the molecular mass. So you see over here, this also should give you the same formula that we have calculated just now, that is butanoic acid, because this is the same question. Now here I had told you that I am going to explain to you what is vapor density. So let's go on to that. To understand vapor density, I'll correlate to what you already know from your knowledge in physics. Relative density, the density of a substance compared to the density of water at 4 degrees Celsius, or mass of a certain volume of substance divided by the mass of same volume of water at 4 degrees Celsius. So, when we have to express the density of a gas, instead of taking water as a standard for gaseous substances, hydrogen gas is the standard, and we measure or take the values of both the gases under the same conditions of temperature and pressure. We are talking about STP. So, vapor density is mass of certain volume of the gas divided by the mass of same volume of hydrogen under the same conditions of temperature and pressure. Now, if those same conditions of temperature and pressure are STP, and the volume of the gas and hydrogen that I am taking is 1 molar volume, that means volume of 1 mole at STP is what I am taking. So, vapor density is mass of a molar volume of the gas divided by mass of molar volume of hydrogen at STP. Vapor density is equals to mass of a molar volume of gas is nothing but its relative molecular mass, right? If you are not clear about this, please watch the video on the mole concept. Mass of a molar volume of hydrogen, that is the RMM of hydrogen. And what is the RMM of hydrogen? It is 2. So, relative molecular mass is nothing but twice of vapor density. See, you've learned so much today. Now, would you want to enforce or make it stronger? Would you like to make this learning stronger? Very good. If you are keen to help yourself in understanding the topic better, please practice questions on this topic. And how many will you practice? 7 questions. Okay, 7 questions in all, and at the end of doing these 7 questions, I am sure this will turn into a smile, right? And that's what I want to see at the end of it all. Stay safe, stay healthy, and stay subscribed. There is more to come.